Hi and welcome to today's class. So today is the 24th of April and we're going to have our third lesson in probability. So this will finish off what we need to know about probability, and next week you're going to be working through the exam questions. Use these videos to come back and check up on anything as you are working through the exam questions. So today we're going to talk about relative frequency. We're going to talk about experimental probability, they're both the same thing, and then we're going to talk about expected frequency. So just looking at the list of things that we said we needed to cover in probability, we've covered our probability scale, calculating probabilities and multiple events. We did that in our first video. In yesterday's video, we looked at listing outcomes that included the fundamental principle accounting. And today we're going to look at expected frequency and the relative frequency experimental probability. So expected frequency, let's break that down. Expected, so what do you expect? And frequency is the number of times. So expected frequency is the frequency of an outcome based off the probability. So let's think about this example. If I roll a dice 120 times, how many times would I expect to get a 5? Well, let's ask the question, what is the probability of getting 5? So if I want to roll a dice, what's the probability of getting a 5? So there's 1 5 on the dice out of 6 possible outcomes. So the probability is 1 in 6. So that's telling us that out of every 6 times, one of them will probably be a 5. So how we use the probability to get the expected frequency, so I'm going to shorten that, expected frequency, we simply multiply the probability, so a sixth, by the number of times that we do the event. So this time we're rolling that dice 120 times. Put that into your calculator and we will expect to get a 520 times. So let's see how we could use that in an exam question. Anya and Mark are playing a board game with the spinner. They can either use spinner X or spinner Y. To win the game, you must spin an arrow and have it stopped in the sector marked A. Which spinner should Anya choose in order to have the best chance of winning? So if you look at this, the one with the best chance is Y. Why? Because half of Y is A. So if we think about this, so let's divide this into 4 equal pieces, just like spinner X. So in spinner X, I'm just doing it up here because I have more space. So in spinner X, the chance, so the probability of getting an A is 1 in 4. For spinner Y, the chance, the probability of getting an A, although there was only one section, it won't be 1 in 4, because that, when we talk about this in terms of the spinner, each section would have to be the same size. So actually, it's a 2 in 4 chance or a 1 in 2 chance. Remember, I keep telling you, probability is the same as a fraction. So it's the same question as what fraction of the circle is A? So it's a quarter and a half. So this is my explanation here. You have a better chance of winning with spinner Y. Mark plays 12 times using spinner Y. Out of how many of the 12 games would he expect to win? Well, the expected, this is like expected frequency, so he'll expect to win. So probability, so that's a half, multiplied by 12, so he'll expect to win half the time, which will be 6 times. So then we talk about relative frequency or experimental probability. It's better known as relative frequency, but I think experimental probability explains it a little bit better. Experimental probability is the probability that we get from an experiment. So sometimes it can be too difficult to work out the probability of an event, and we need to take emotion and or pressure into account, along with a never-ending list of things that may affect an outcome. For instance, there is an enormous pressure on a penalty taker in football matches. Maybe he'll slip in the rain. So although you might say you can either make the goal or not, the probability is not necessarily 50-50. Okay, same with basketball. If you take a shot, you might get it or you might miss. but that doesn't mean the probability is 50-50. That's only the case for equally likely outcomes. So in the case that we talked about above, we often rely on statistical evidence to find what's called the relative frequency or experimental probability. So basically what we do is we look at what has happened historically, so what has happened before, and use that as a probability. So let's take a look at an example. A penalty taker for a soccer team took 25 penalties during the season. He scored 20 of them. So this tells us roughly what fraction he managed to score, and we can use that as a probability. So although they've asked us what is the relative frequency of scoring a penalty, all we're doing is saying he scored 20 out of 25, and we're going to simplify this. 5 divides into the top and the bottom. So the relative frequency or experimental probability, or just generally the probability of scoring a penalty, is 4 out of 5. When the same player takes 10 penalties next season, how many do we expect him to score? So anytime you see expect, we have the probability multiplied by how many times, in this case, he takes a penalty. And that gives us 8 times. So based off his previous record, we expect him to score 8 times. Discuss the weakness in this system. So obviously this is not perfect. We don't know if those 20 scores he got were scores that were very deserved. Maybe they were playing against really bad goalies. There's a lot of flaws to it. It's not perfect, but sometimes it's the best that we have. If this is a penalty taker's first season, it's not a lot of information. Obviously, the more information we have, the more accurate it can become. So if you have a penalty taker that's been taking penalties for 10 years, you'll have a much better idea. But also, in the case of somebody who's playing for 10 years, they might get better or they might get worse. So it's not perfect. So when they're talking about weaknesses, some of the things that we can talk about, that this is not accurate, it's only an estimate, and that's okay, because sometimes that's all we have. Only one season. Oh, no, it's gone wrong here. So only one season, the more information, more accurate. So maybe he'll get better, maybe he'll get worse, maybe weather. Lots of different things you can put in there. So you can fill in your own, whatever you think you could say about weaknesses. So let's look at an exam style question which talks about relative frequency. I think the hardest part of relative frequency is just the word itself, or the phrase. So a bag contains red discs, blue discs, and white discs. In an experiment, each student in a class of 24 takes out a disc, records its colour, and replaces it. This is repeated 10 times. So we should have 24 students, they each go 10 times. So 24 by 10, that is 240. So let's look at this little table. We had the frequency. So they took out 123 red, 78 blue, and 39 white. So in your opinion, why is the number of red greater than blue or white? So we'd expect that if that came out more, there's probably more red discs. So probably, we don't know for sure, probably more red discs in the bag. So then it asks us to complete the table above. So we have 123 plus 78 plus 39. And that is 240. So the relative frequency is the frequency over the total. So that's 123 divided by 240. This one is 78 divided by 240, and this is 39 divided by 240. So then they say the percentage. So to turn it into a percentage, we multiply it by 100, and we end up with here 51%. So 78 divided by 240, and then multiply by 100, and we get 32.5, and then we have 39, and we get 16%. So actually I'm going to round up that 32, they didn't tell us about anything, I'm going to round it up to 33%, so we don't have any decimals. So we have 51%, 33%, and 16%. Use the results from your table to get an estimate of probability for getting each colour when the discs are taken from the bag. So a probability is basically the same as the relative frequency, but we generally write those in, I would say, fractional form. So this would be 123 out of 240, which is actually 41 out of 80. The other one is 78 out of 240, and that's 13 out of 40. And the last one is 39 out of 240, which is 13 out of 80. So these are just these numbers simplified. I simplified them by putting them into my calculator and pressing equals. When you put a fraction into your calculator, it will always give it back to you in its simplest form.